What is a matrix? A rectangular array of numbers, letters, or expressions. Enclosed between two square brackets is called a matrix. For example, 2, 4, 3, 6, 5, 1, minus 2, 9, 3, 5, 1, 8. So this kind of series or array, which is written in the shape of a rectangle, is called rectangular array. So this is the rectangular array of numbers enclosed between two square brackets. So this is a matrix. These are called rows of the matrix, which are generally denoted by R1, R2, R3, and so on. And these are called the columns of the matrix, which are generally denoted by C1, C2, C3, C4, and so on. And a matrix can have any number of rows and any number of columns. The number of rows and number of columns may be equal or unequal. Now, let's talk about order of matrix. Order of a matrix. Number of rows times number of columns is called order of the matrix. So if we talk about the order of the above matrix, its order will be 3 by 4. 3 times 4, and first number always indicates the number of rows, and the second number always indicates number of columns. Now let's talk about notation of a matrix. Generally, a matrix is denoted by a square bracket Aij, square bracket closed, m by n, m times n, where m times n is the order of the matrix, and Aij denotes belonging to ith row and jth column. For example, A is a matrix matrix 4 3 5 8 7 minus 1 9 2 6. So its order is 3 by 3, and if we denote it by square bracket Aij 3 by 3, then this element belongs to the first row and the first column. So the first element of the first row is denoted by A11. So we write A11 is equal to 4. In the same way, if we talk about 3, it is belonging to first row and second column. So it is denoted by A12. A12 means the element of first row and second column, which is 3 in this matrix. Similarly, 5 is A13. It is denoted by A13, that is equal to 5. If notation for this element 8 will be A21, that is the element of the second row and first column. 7 is A22 minus 1 A23. 9 A31, the element of third row and first column, and A32, that is the element of the third row and second column, which is 2, and A33, that is the element of third row and third column, which is 6. Now suppose we need to find a matrix of order two by 3 such that Aij is defined as I plus j square upon 2. So Aij is defined by the identity bracket I plus j whole square upon 2, and we need to create a 2 by 3 matrix. So what is the way to do that? So first we assume a 2 by 3 matrix. Let matrix 2 by 3 means 2 rows and 3 column must be there. So first row will be A11, A12, A13, and the second row will be denoted by A21, A22, A23. So in that way we assumed a 2 by 3 matrix. Now we will find A11, A12, A13, A21, A22, A23 by this given relation. So first A11. If we write A11, that means I is equal to 1, j is equal to 1. So putting I is equal to 1, j is equal to 1 in this formula, we write 1 plus 1 whole square upon 2. That is 2 square, that is 4 upon 2, which is equal to 2. Now A12, now A12, that is I is equal to 1 and j is equal to 2. Now putting I is equal to 1 and j is equal to 2 in this relation, 1 plus 2 whole square upon 2. 1 plus 2 is 3, 3 square is 9, so we get 9 upon 2. Now A13. Here in A13, if the suffix is A13, That means the first row I is equal to 1 and third row column, that is j is equal to 3. So putting I is equal to 1 and j is equal to 3 in this relation, we get 1 plus 3 whole square upon 2. 1 plus 3 will becomes 4. 4 square is 16. 16 upon 2 is equal to 8. Next, we have to find A21. So here in A21, I is equal to 2 and j is equal to 1. So we get 2 plus 1 whole square upon 2. That is 2 plus 1, 3 square, 9 again, 9 upon 2. And A22, that is I and j both are 2. So we have 2 plus 2 whole square upon 2. That is 2 plus 2, 4. 4 square is 16. 16 upon 2, that is 8. And finally, A23, the last element. Here I is 2 and j is 3. So putting I is equal to 2 and j is 3 in the relation, we get 2 plus 3 whole square upon 2. 2 plus 3 is 5. 5 square is 25. So 25 upon 2. Now, after obtaining all these elements, we need to substitute them in this assumed matrix. So now A11 is 2. A12 is 9 upon 2. A13 is 8. A21 is 9 upon 2. And A22 is 8. And A23 is 25 upon 2. That's it. Now we will discuss some specific types of matrices. As you know, the matrices is the plural of matrix. So let's talk about some specific types of matrices. Number 1, a row matrix. A matrix having only one row and any number of columns. Is called for example, matrix 4, 5, 3 is a row matrix because it has only one row and 3 columns. So a row matrix can have any number of columns, but number of rows will be 1 only. And thus we may give any example having 2 columns or 3 columns or 4 columns and so on. But in every row matrix, row must be 1. So this is another row matrix. This is another row matrix. Second, column matrix. Having only one column and any number of rows is called a column matrix. For example, matrix 8, 9 as one column and 2 rows. So we have only one column in this matrix. That's why this is a column matrix. Four, 5, 3, 8 is one column in this matrix and 4 rows. So this is also another column matrix. In this example, there is only one row and three columns. So its order will be 1 by 3. 1 by 3. This is a 1 by 3 matrix. In the same way, second matrix, this one matrix has the order 1 by 2 because there is only one row and two columns, and the third row matrix has the order 1 by 4 because there is only one row and four columns. In the example of column matrices, the first matrix has only one column and two rows, so 2 by 1 is the order of this matrix, as we have discussed. In the order, the first number always indicates the number of rows and the second number always indicates number of columns. So 2 by 1. And in the same way, the order of the next column matrix is 4 by 1. 4 rows and 1 column. Now, third one is a square matrix. A matrix is said to be a square matrix if it has exactly equal number of rows and columns. That is, if there are 2 rows, there must be 2 columns, and 3 rows, so there must be 3 columns. For 4 rows, 4 columns. So we may give example for a square matrix like so this is a square matrix of 2 by 2 order because there are 2 rows and 2 columns. So the next example is a square matrix of 3 by 3 order because there are 3 rows and 3 columns. So 3 by 3. Now let's talk about fourth matrix, which is a null matrix. A matrix is said to be a null matrix if every element of it is 0. So for example, zero, zero, 0, 0. So this is a null matrix of order 2 by 2, which is generally denoted by O, 2 by 2. Fifth is identity matrix. A square matrix is said to be identity matrix if its every non-diagonal element is 0 and every diagonal element is 1. A square matrix, that means it must be a square matrix as well. That means the number of rows and number of columns in every identity matrix will be equal. So it can be an identity matrix of 2 by 2 order, or 3 by 3, or 4 by 4, and so on. So example, identity matrix of 2 by 2 order is 1 0 0 1. This is always the leading diagonal of a matrix, top left to the bottom right. This is called the diagonal of a matrix, and the elements in the diagonal are called diagonal elements, and the elements which are not lying in the diagonal are called non-diagonal elements. So this is a matrix of 2 by 2 order in which diagonal elements are 1 and every non-diagonal elements are 0. So this is an identity matrix which is generally denoted by uppercase I, 2, or uppercase I, 2 by 2. In the same way, identity matrix of 3 by 3 order (1 0 0 0 1 0 0 0 1). This is identity matrix of 3 by 3 order, and it is denoted by I3 or I 3 by 3, and so on. Now, sixth specific kind of matrix is a scalar matrix. A square matrix is said to be a scalar matrix if its all diagonal elements are non-zero and equal, and its non-diagonal elements are 0. For example, matrix 2 0 0 0 2 0 0 0 2 is a scalar matrix because all the diagonal elements are equal and non-zero, and all the non-diagonal elements are 0. So this is a scalar matrix of order 3 by 3. Like 5 0 0 0 0 5 0 0 0 0 5 0 0 0 0 5. So this is an example for scalar matrix of 4 by 4 order. Now diagonal elements may be any number but equal, 6 6 6, 4 4 4, 3 3 3. But the definition is a square matrix is said to be a scalar matrix if its all diagonal elements are non-zero and equal, and its non-diagonal elements are 0. Now let's talk about a diagonal matrix. Square matrix, square matrix in which every non-diagonal element is 0 is called a diagonal matrix. Or in other words, we can say that a square matrix in which every element above and below its diagonal is 0 is called a diagonal matrix, because every element which is not lying in the diagonal of a square matrix is said to be a non-diagonal element. So in other words, we may define it as a square matrix in which every element above and below its diagonal is 0 is called a diagonal matrix. For example, four, 0, 0, 0, 3, 0, 0, 0, 1. So as you see, every element above and below the leading diagonal is 0. So this is a diagonal matrix. A diagonal matrix like this is denoted in short as diag parenthesis 4, 3, 1. That means only diag, and within parentheses we specify diagonal elements. This is the way to denote a diagonal matrix. Next specific type of matrix is upper triangular matrix, a square matrix is said to be an upper triangular matrix if every element below the leading diagonal of the matrix is 0. A square matrix is said to be an upper triangular matrix if every element below the leading diagonal of the matrix is 0. For example, four, 2, 5, 0, 1, 3, 0, 0, 2. So as you see, in this square matrix of order 3 by 3, every element below the leading diagonal is 0. So this is an upper triangular matrix. So let's define a lower triangular matrix like upper triangular matrix, a square matrix in which every element above the diagonal of the matrix is 0 is called a lower triangular matrix. Five, 0, 0, 0, 1, 3, 0, 0, 2, 4, 6, 0, 1, 3, 7, 8. So as you see, above the leading diagonal, every element in this square matrix is 0. So this is a lower triangular matrix.